Something going on in this row. All right, let's do this because I am sure the questions that we have, more than one of you have the same question. So let's take a look at the homework. First section, simplify the expression. So which ones do we need on 36 through 44? Or 36 through 44. Any of them hard? So a couple people asked me about number 38. Excuse me. I have the answer written as 9 times 8 to the 3/4. They asked if they could have this as the answer. You could have it like that. You could have it, my board's being goofy, like that. So there's 3 ways you could write that answer. Questions there? All right. Any other questions through 44? Okay, how about 46, 48, and 50? Do we need to talk about any of those? Are you good? 48?
No, 50. I meant.
50. Okay, yeah, 50 was hard. Who said 50?
Oh, yeah, 50.
Yeah, 50 was, I had a lot of people ask me about 50 yesterday. There's many different ways to start this problem, but I personally think the easiest way to start this problem is to start by doing n divided by n and p divided by p. When you are dividing powers, what math do we do? Subtraction, right? So I have the 8th root and then 2 minus 18. What's 2 minus 18? Negative 16. And now be careful. What's negative 1 minus 7? Negative 8. Now, I don't like negative powers, so where are those negative powers going to go? To the bottom. So I get the 8th root of, and then these drop to the bottom. I put an n to p to the 8, and those become positive. Now I take the 8th root of each piece. So I'm going to take the 8th root of 1, the 8th root of n to the 16, and the 8th root of p to the 8. 8. Now keep in mind up here, it does not say anything about the variables being positive. So you do have to worry about absolute value when needed. So what is the 8th root of 1? What multiplies 8 times to give you 1? 1. And then if I have 16 n's, how many groups can I pull out? 2, and that's in the denominator. Do I need to worry about absolute value there? No, because an n times an n is going to be positive. Okay? Now, how about here? If I have 8 groups of p, how many p's can I take out? How many groups of 8? 1. But now do I need to worry about absolute value? Yeah, because that p has to be positive. You cannot take the 8th root of a negative number. Questions there? That's a good one to do. That was a hard one. I had a lot of questions on that one yesterday. Okay, any other questions through 50? Okay, how about the next group? Now we're assuming all variables are positive. 62 is one I got a lot. 60 and 62. Do we need either one of those? Both? Okay. So on number 60, when I looked at number 60, I first did the same thing I did in the other one. Look at your numbers, 405 divided by 5. I did x to the 3rd over x to the negative 1. So let's start with 405 over 5. What is 405 divided by 5? Well, how many times is 40 divided by 5? 8. And then 5 by 5 is 1. So I got 81. Now, what do you do here when you subtract? You do 3 minus negative 1. What's 3 minus negative 1? X to the what? 4. 3 minus negative 1 becomes 3 plus 1. And now I'm left with, I got y's. I just missed, I thought those were different letters. I thought this was a different problem. Here we got y to the 3rd and y. What do you guys do there? 3 minus 1. What's 3 minus 1? 2. Now take the 4th root of each piece. What's the 4th root of 81? 3. What's the 4th root of x to the 4th? x. But it says assume all variables are positive, so I don't need to worry about anything. I'm just going to put x. Now, if I only have two y's, can I take a group of 4 out? No. So I'm just going to write 4th root of y squared. If you got that far, I would say you're doing really good. This is one of those problems that has a little extra oomph to it that I will not put on a test. Remember, this 4th root of y squared can be written using rational exponents. How would you change it to rational exponents? It'd be y to the what? 2/4. And how do you rewrite y to the 2/4? It'd be y to the... Okay, well, how do you rewrite y to the 1/2 using radicals? This just means y to the what? Square root of y. And that's how I finished it. But if you got the step up above, I'd say your understanding is good. Understanding is good. Okay, 62. On 62, same thing. I'm going to start here. I'm going to go here. I'm going to go here. So 7/56. Guys, it's just, if I gave you the fraction 7/56 and told you to reduce it, what would you tell me it reduces to? 1/8. So 1/8. Now, x's, subtract. What is 3/4 minus negative 1/2? Well, 3/4 minus a negative becomes plus a positive. What's 3/4 plus a half? Well, this is 3/4 plus how many fourths? 2. So how many fourths do you have for your x? 5/4. And now the y, I do 5/2 minus 1/4. Well, how many fourths is 5/2? 10. So how many y's do you have? Y to the what? 9/4. And then are we happy with where z is? No, because it has a what? Negative. So since it's in the bottom, you move it to the, if it was in the top, you move it to the bottom. But it's down there, so we move it and make it positive. Now is everybody happy? Do you have to have the 1 in the numerator? No, you can, but you don't have to. Questions on any of those? Anybody need 56 or 58? Okay, and how about these last group? How'd you guys do on 64 to 68? Anybody need any of those? Okay, pass those in and get out a sheet of paper that you can do some review problems on. We are not doing all of these, so don't just start. I'm going to circle them. We're just going to pick and choose. Hang on, I'm missing one from this room. Oh, I took it from you. Never mind, my fault. All right. So we're going to do a couple problems for review. We're not doing all of these. I have some circled that I felt like were important. But these two are the first two that are important. So do numbers 1 and 2. 1 and 2. This is from section 5.1. Find the indicated real nth root or roots of A. Some of you are using your calculator, which is fine. Kaden, what are we asking you to find? What am I asking you to find here in this first one, number 1?
All the third roots from 343.
Yeah, all the third roots of 343. What multiplied 3 times to give you 343? Did you find it? Okay, so if you don't know, remember to find the cube root, you're going to go under math. Oh, goodness gracious, I am not sure what just happened there. Okay. What in the world is happening to my calculator here? Okay. You're going to go math, and cube root is number 4, and then 343. Now, this one is always going to give you the positive. If there's 2, it won't give you the negative, but cube root, there's only 1. So what's the cube root of 343? 7. Do you need to worry about a negative when it's cube root? Think about it. What multiplies 3 times to give you a positive? Does a negative multiply 3 times to give you a positive? No. So it's just 7. Just 7. What about this one? What about this one? Quinn, what'd you come up with here? What is it asking you to find first, Quinn?
The 6th root of negative 64.
All 6th roots of negative 64. I'm not going to touch my calculator because I know there's what?
None.
There's none. Does anything multiply 6 times to give you a negative number?
No.
So there are what? No real roots. Now, what if I gave you this one? What if I said n is 2 and a is 100? What am I asking you for there? Everybody, I'm asking you for all what? All square roots of what? What are you guys going to tell me? Oh, I'm hearing absolute value. Yeah, what multiplies twice to give you 100? 10 and 10 and negative 10 and negative 10. So this is the one you have to put the plus or minus. Does that make sense, AJ? Okay. Good there? All right, here's the directions, but we're not doing any in this row. Find the real solutions, round to 2 decimal places if necessary. So solve, round. Do number 19. X to the 3rd plus 17 equals 57. Right? Caleb, what'd you do? And when you subtracted 17, what'd you get?
40.
X to the 3rd equals 40. How'd you undo x to the 3rd?
Take the cube root.
Cube root. So is the cube root of x a perfect cube? What multiplies 3 times to give you 40?
Oh, sorry.
No. So this is the one that said if it's not a perfect number, you can use your calculator. So when you did the cube root of 40, what did you get? 3.42. Good. Do I need a plus or minus? No, not on an odd root. Not on an odd root. Very good. All right, do 20. All right, Cash, what'd you do first?
First, I divided by 1/5.
Good. You can divide by 1/5 or you can multiply by 5. Either one of those would work. And when you do, you got x to the 4th equals what?
6.
625. Now what'd you do?
4th root of both sides.
Take the fourth root of both sides. Now, I saw a lot of you grab your calculator. That's fine. If you do fourth, math, number 5, 625. And what's your calculator tell you? 5. But you have to be smarter than your calculator. Plus or minus 5. Why did we have to put a plus or minus there? Because 5 times 5 times 5 times 5 is positive 625. And negative 5 times negative 5 times negative 5 times negative 5 is positive 625. Questions on that one? Okay, that was all 5-1. 5-2. Do number 3. Simplify. 11 to the 3 halves times 11 to the negative 5 halves, all raised to the negative 1/3. Properties of your exponents, your exponent rules. Chloe, what math do you do when you multiply powers? You don't multiply them. Multiply powers, we add the exponents. So you're going to add 3 halves and negative 5 halves. What do you get when you add 3 halves and negative 5 halves? And what is negative 2 halves reduced to? Negative 1. So most of you will start here with my green work. My blue work's just how I got there. Now, power of a power. Chloe, what math do you do here when you have a power of a power? Multiply. And what's negative 1 times 1/3? Negative 1 times negative 1/3. I'm sorry. Chloe, you're overthinking this. What's a negative times a negative? And what's 1 times a third? Okay, there you go. And now, guys, are we done? Yep, we're done. Questions there? All right. Next ones, I want you to do 13 and 14. These are the ones where you have to make a perfect cube in the denominator. All right, Josh, can you reduce 4 over 9? Those are both underneath the radical. I always check that first. No. So you need to multiply by something to give you a perfect cube. So I always start with 2 to the third. What's 2 to the third?
8.
Can you turn 9 into 8? What's 3 to the third?
27.
Can you turn 9 into 27? Yes, by multiplying it by what?
Cube root of 3.
Cube root of 3, and now I get the cube root of 27. Well, whatever you multiply by the bottom, you got to multiply by the top. So what's the cube root of 4 times the cube root of 3?
Cube root of 12.
Cube root of 12. Okay, can you break up cube root of 12 into any of these? So you have the cube root of 12 over what?
3.
Yeah. And now you're done. You cannot have a radical in the denominator. You cannot have a fraction under the radical. Good. Questions there? Okay, the next one is Jarrett. Yours is very similar. So Jarrett, looking at yours, can you reduce 4 over 25?
No.
No. So I rewrite it as the cube root of 4 over the cube root of 25. And now I go back to my perfect cubes. Can you turn cube root of 25 into 8?
No.
How about into 27?
No.
So keep going. What's 4 cubed?
16. Wait, no.
4 times 4 is 16. Times 4 is...
64.
Okay, can you turn 25 into 64?
No.
What's 5 cubed?
125.
125. Can you turn 25 into 125?
Yes.
Yes. We can turn this into the cube root of 125 if I multiply by what?
5.
Cube root of 5. Whatever you do to the bottom, you do to the top. So what do you get in the numerator?
20.
Cube root of 20. So can you break cube root of 20 into any of those? Can you simplify it?
No.
Nope. So you get cube root of 20 over what?
5.
How'd you guys do on those two? We're not going to do 16. We're just going to talk about it. Be very careful. What would you guys multiply your complex, or I just told you, what would you multiply your denominator? What would you multiply both by? 5 plus square root of 3. Top and bottom. And FOIL and distribute and go from there. All right. Next one, simplify. I want you to do number 21. Trying to hit one of each type you're going to do tonight. I made my son change his flights that he'd get home on time because of the snow. And he was so delayed last night. By like 6 hours, he got home at 2 in the morning. And his flights totally would have been on time if he would have stayed on his flight. Figures. All right. Oh, well. All right. You guys ready? Number 21, Karina. All right. Karina, I taught you a little trick yesterday. What did I teach you guys yesterday? Try to divide 375 by what? Well, okay, or by 3. And you get 125. Is that a perfect cube? Try it. See if it works. That helps you to know what to break this up into. So you broke this up into what?
325.
And what's the cube root of 125?
5.
So 13 cube root of 3 minus 5 cube root of 3. What did you get for an answer?
8, and then the cube root of 3.
Perfect. Gosh, I gave you guys way too much time on that. Was that easy?
Yeah.
Okay. Last one is number 27. Last one. Ah, done jumped on me. The board does that. It drives me crazy. The 7th root of n to the 12th, p to the 3rd, over n to the negative 2nd, p to the 24th. See if you guys can get this. You're not ready? What do you do, Natalie, to the ends?
Adam.
Okay, yeah, you add them because it was subtract, and when you subtract minus a negative, it becomes positive. Do you guys have? So she did 12 minus negative 2, so you got the 7th root of what?
14.
End of the 14. And then what did you get here when you did 3 minus 24? You got p to the what?
Negative 21st.
Can you leave a negative power?
No.
So where does it go?
The bottom.
So you got the 7th root of n to the 14th over p to the 21st. All right. It says all variables are positive, so I don't need to worry about absolute values. If you have 14 n's, how many groups can you take out in the numerator?
2.
If you have 21 p's, how many can you take out in the bottom?
3.
Done. How'd you guys do there?
I set both of them down. Is that wrong?
Yeah.
You did what?
I set both of them down. We need to put the 21 in the bottom.
Yeah, the n does not go to the bottom because 12 minus negative 2, that's positive, so it stays in the numerator. The p is the only one that has a negative, so it's the only one that goes down. That make sense? All right, rest of class time, 10 minutes. Get started.